Afternoon, everyone, and thank you for joining us, especially after what I'm sure has been a busy school day for most of you. My name is Ciara Walsh. I am a commissioning editor here on the primary team at Folens. It's been an absolute pleasure for me to work on the development of Maths My Way over the last several years. And I'm joined this afternoon by Patrick Neary, who is our series editor and co-author of Maths My Way First to Sixth Class. And today we're going to take a little look at mathematical modelling. So before we kick off, just a bit of housekeeping. So this webinar is being recorded, so do not worry if you are in the middle of driving home from school and you're just listening in, or you're cooking dinner or whatever it is that's going on. It is being recorded, so you can watch it back later on and share with your colleagues if you'd like to. We are mostly aimed at Maths My Way users here because we are going to use examples from Maths My Way, but if you are not using Maths My Way, please do still stick around, because you will find something useful in it for you in regard to mathematical modelling in the new curriculum. We are mostly going to be focused on first to sixth class today, so not so much in the kind of infant side of things, but again, if you're an infant teacher, stick around. There's lots in this for everyone to take away. We will be including some content which you will find relevant if you're in a multi-grade setting or you're working in SET, but we will not be looking specifically at either of those in today's webinar. And then finally, we will have a Q&A session at the end. So please feel free to use the chat functionality to ask questions throughout. And then I will put them to Patrick at the end. And generally throughout these webinars, I'm in the chat anyway, and I'll answer any questions that I can as we go, and keep the rest for Patrick. So without further ado, I'm going to hand over to Patrick, and he's going to take you through some mathematical modelling.
Great. Thanks a million, Ciara. Just share this. So at this stage, it seems we've done so many of these webinars that it seems silly to introduce myself again, but in case it's anyone's first, my name is Patrick Neary. I've been working on Maths My Way for the last couple of years now as series editor across all the books from first to sixth class, and authoring some of the units as well. And I'm also using the third class version with my class this year. So lots of seeing it firsthand in the classroom as well, and some would give you some tips throughout this evening. Before we get started, we're going to be talking about modelling with Maths My Way, but also just mathematical modelling in general. But I really just want to emphasize that, we are all doing absolutely amazing work in our classrooms. Anyone who is engaging with the new curriculum, who is trying to try out new things with their students, you're doing so much already. So hopefully you get a few tips or things that you want to try out from today's session. But I really want to start off with that message that, we are all doing our best to get to know this new curriculum. Anyone who's here this evening is even going above and beyond, giving up their free time to learn more and to engage with it even more. So really do praise yourself for that it is, we are all really trying with it, and it is a brand new curriculum. We're only, it's going to take years before it's fully implemented. That said, one of the questions I sometimes get asked is, what will I do if I get notified that we're having a maths inspection? What should I focus on? Because the curriculum is so new, there's so much in it, you cannot focus on everything. So I'd say start by thinking about, well, what are we doing well? What's working well in our school? And what's one thing we could focus on? And for that, I'd really emphasize reasoning and communicating. And they're things that are so embedded in mathematical modelling that we're going to talk about today. So reasoning, like how are children grappling with mathematical ideas? How are they problem solving? How are they making sense of maths? And communicating. And that's both how are they modelling? How are they showing their thinking? And also how are they using maths talk? Are there opportunities for chat and discussion? So they're just two things to keep in the back of your mind, as we go through these activities and some of the theory behind it. Even though we're talking about modelling, where is reasoning being developed as the children work, and where is communication being developed? Where are the opportunities for maths talk? So I'm sure everyone at this stage is very familiar with this visual from the curriculum, the 5 key pedagogical practices. And so that this is just to really ground today's session, that it's in one of these pedagogical practices, but to really emphasize that they're very interconnected. That's the whole point of the visual as being a jigsaw, that, by doing one, there's knock-on effects in all of them. So by choosing one to focus on, like mathematical modeling, and having that as your emphasis with your class, you're also going to see more maths talk. You're also going to be using more cognitively challenging tasks. It's also going to be more playful, and hopefully we're also developing that productive disposition in our students. So it's all interconnected, and by focusing on one, it'll have benefits in all of these areas. And then, after like choosing one thing to focus on is definitely more than enough at a time, and build it up gradually as we go. So when we think of mathematical modeling, I guess the first, like, it's quite a new term in the curriculum, and next we're going to look at what exactly is it, or what does the curriculum say it should look like in our classrooms. So this is directly from the curriculum, the new STEM curriculum, and from page 86 there, and it goes through what emphasizing mathematical modeling should look like. And there's just a couple of sentences in particular I want to focus on. So the first one here is that children naturally generate their own informal mathematical models in a way that is context specific and makes sense to them. And here the real buzzword is, or the real thing that's important, is that it's informal and that it makes sense to them. So with the old curriculum, maths lessons might often have started with the teacher showing something on the board and then the children copying that, or the children using that way to then solve different questions, to solve different problems. But it all starts off with the teacher showing and then the children copying. And that's not to say that doesn't happen this news part doesn't say that doesn't happen anymore, but it's just giving us a different starting point. So that we start off with contexts and scenarios that prompt the children to come up with their own ways to solve these problems. We're trying to build that idea of sense making, that it's not just learning off a series of steps, but that it's that they're doing it in a way that makes sense, that's logical. It kind of, when I was trying to think of a real world example that reminds me of this, and I was thinking of driving. And recently I was going down to a wedding venue, to a friend's wedding in Wicklow. And I was thinking about where the venue was, what was the nearest town. But instead of reasoning about how to get there, I did what most people, I think, do, and popped on Google Maps and started to follow it, which is great. Google Maps and other map softwares, equally, they'll get you there in what they say will be the quickest amount of time possible. But it doesn't take into account the fact that I ended up down a narrow lane with grass up the middle of the road, and I was there panicking, thinking, would any car try and come the other way, and I'd have to reverse and find a gap. So while the formal mathematical models are very good in that they're an efficient way to do something, they mightn't always be the way that makes the most sense, or there might be a more logical way to solve something. Even thinking about that question, 1,000 take away 5. Are you going to use column subtraction to do that and have to do all the crossing outs of the zeros? And there's it's about building up that sense making in our students. One other thing I'll mention on this is that if you're doing a new topic with your class, a topic that they haven't spent that much time on previously, they'll get on so much better with this than a topic that they've experienced lots of old curriculum style teaching on. So if they're used to solving subtraction by following a method, and that's very much drilled into the children and it's ingrained in them, it's very hard to reverse engineer and go back to this mathematical modeling. My experience is that I found when you're doing a new topic, that's when it really comes to the fore. So like teaching multi-digit division in fifth class. It's the first time they look at that, so it comes more naturally to them. Whereas if they've already done the drill and practice, it's harder to go back and start the informal methods then. The second thing is just what modeling can look like. And it's not always concrete materials. So the curriculum here states that it can include physical actions, spoken words, objects, images, symbols, or written words. So it takes all of that in. And I find one of the most powerful tools that we have in our classrooms is the whiteboards. And that whole idea of doodling, sketching, visualizing problems, visualizing models, and children moving from using physical resource to then maybe drawing pictures of that resource to help them solve problems. Something I've seen with fractions, like when children move from maybe paper folding to then drawing models or bar models to help them solve problems. It's a really powerful way of engaging with the maths that's going on. Finally, then, what's valued is the exploration, that idea of doing things in a sense-making way rather than just following step by step, and building conceptual understanding and flexibility. So it's not about always getting the right answer or being the quickest to solve it. It's about flexibility and really building sense making among our students. The curriculum also gives, with that explanation, it also gives some tips on how we can emphasize mathematical modeling. So the first three highlighted here are all about providing opportunities, the type of tasks we're using, and just having these situations in our classrooms. As I mentioned at the start, all of the practices are interconnected. So this connects back with using cognitively challenging tasks. And it's what tasks are we using to elicit modeling? And that's really where Maths My Way comes in. One of our huge aims was to have this type of activity front and center in the series, so that you're not trying to come up with this on the spot, so that it's there for you. So we have the opportunities there. And as I said, as the children use it for a number of years, it'll get easier for them. And as they encounter new topics, it's easier to use mathematical or to develop mathematical models for something that they aren't already familiar with. Some other tips then, these all focus around the idea of individuality, so that there's freedom and autonomy for children, that there's individuality, there's choice, there's independence, and there's an element of creativity in it. So that different children's ideas are praised, that like if a child comes up with a way of solving something, that their idea is drawn up on the board with their name beside it, or maybe they're brought up to show us themselves, that they're celebrated, that it's having a different way that someone else hasn't come up with already is something that's praised and encouraged in the classroom. So after looking at the theory, it's a nice time to go back and see maybe some examples from the classroom. And I was very lucky to work with Dr. Shuan McVurry from DCU a number of years ago on how this would look with teaching multi-digit division in fifth class. So it was their first time looking at it, and together myself and Shuan came up with a series of lessons that would help to bring out this type of thinking in the classroom. And the next excerpts and the images you'll see are from paper we put together on it. But I've put these in to show that while it's in the curriculum, there's also international research to back up this idea of modeling and children coming up with their own strategies, and to see what it could look like when it organically happens in a classroom. The first point here is all about the idea that there's two different types of models. So me as a teacher, I can stand up in front of the class and I can show something, or I can draw something. And that's me generating the idea, or the teacher modeling maths. But something that's a little bit different is the child coming up with the models themselves. And that's really what the curriculum is looking for, and what research shows helps children to develop more meaningful solutions and to engage in reasoning. if they're actually thinking about what's going on. Similarly, in this quote, we're talking about algorithms. So long division, I'm sure everyone is familiar with that algorithm where you put one number in the hat on top and you're following the different steps to find the answer. And yes, they're really useful at when you need to complete a number of calculations quickly. But in today's world, that skill is becoming less and less important. So the idea of being able to find an answer to a calculation quickly, like nowadays, the children can ask Siri, they can ask Alexa, they can ask ChatGPT. There's all of these things that can calculate quickly. But the skills that we need the children to develop are the reasoning skills, that they can think flexibly, that that there's more opportunities for them to build up those critical thinking skills. So from the work that we did, here are some examples of how children in that 5th class solved multi-digit division calculations. And what's just to give a bit of background about it, so we came up with the lessons together. All of the lessons started with a word problem, a very simple word problem, just putting it in context, but it was always a simple calculation, kind of a 3-digit number that would then be divided by a 2-digit number. But deliberately at the start, we did not show them the way that you usually find in a textbook for solving long division. We wanted the ideas to come from the children themselves. The numbers started quite small, so the children would have started by just using repeated subtraction, and they could easily find the solutions. And then as the numbers got harder, they had to come up with some different ways to solve the calculations. So the first 2 examples there are what we called low-level chunking, where you can see in the first example, 72 represents 4 groups. So they were multiplying 4, or they were taking away 4 groups at once. And the second example, they were using repeated addition, but they didn't just keep adding 27 and 27 and 27. They started adding 54s as well. They started adding in different bits and pieces there to make it more efficient as they went. The next way a child came up with was what we called high-level chunking. So here they were dividing by 34. And as they started, they said, okay, 1 group is 34, 2 groups is 68. Then this child loved doubling. So then they said 4 groups, 136. They kept going up and up and up until they got 16 groups is 544. And using those bigger numbers, they were able to use repeated subtraction to figure out how many groups of 34 were in 736. And finally, you have where the child was decomposing the divisor. So here it was divide by 25. So they divided by 5 first, and then they divided by 5 again. So all of these different ways came up organically in the classroom. One child would come up with an idea. We'd put it up on the board, write the child's name beside it. Then the conversation could go to, whose way would you like to try out next? And we'd do another calculation where they'd try out someone different, someone else's way. And next they'd, at the end of each lesson, they'd say, today I used, and they'd describe how they solved the problem. And tomorrow I'm going to try. And they might want to continue using their own way, or they might want to try out someone else's. So I just thought these were lovely examples of what modeling can actually look like in a 5th class classroom. And again, here, there was no concrete materials. There was no, there was no resources, particularly apart from paper, whiteboards, and the children coming up with their strategies. So it was the children generating the models themselves. So then when we came to putting Maths My Way together, the question was, well, what does this look like in Maths My Way? Or how can we transfer opportunities for this type of thinking to come up within Maths My Way itself? So here's a page from Division 1 in 5th class, but a similar approach is used when a new topic is introduced throughout the series. So you see, it starts off with the part A and part B and part C, which is trying to elicit this type of thinking. So it starts off with the school is organizing chairs for a school event. How many chairs there are, how many rows there will be. And we're asking the children to use one method to solve and another method to check, to try and see what different ways can they come up with. In part B, we're asking them to draw to start to get that idea out, and different. And then in part C, there's a different set of numbers to see, just to refine the thinking and to give another opportunity to see what they can come up with. So hopefully this activity would then bring up some of the models or some of the similar ideas to what I showed on the previous slide. This is very new, and one of our challenges was, what if people feel stuck, or teachers wouldn't like, maybe if you had no idea what the children might come up with. So that's where the teaching slides really come in next. So on the teaching slides, after activity A, there's this series of ideas that our characters introduce. And these are things that the children might have come up with themselves. Now, if this has already come up in your class, if a child has already come up with this way and you've already had a whole class discussion on it, there might be no need to spend time. Like if you've gone through it beforehand, you know what's coming up. And if you've already spoken about this, there might be no need to go through each slide individually. There's different ways there, but if you've already have had enough class discussion, if you've had your opportunity for maths talk where children have been explaining how they solved it, then the slides here you could possibly skip. Or you might decide that one of these ways that's up on the slides is really useful and you really want to focus on one of these ways. For example, Pulse's way here, where they split 32 up into 8 times 4, and they divide by 8, and then they divide by 4. That might be a way that you really want the class to look at. So you might decide, we'll have our class discussion, then I want to look at Pulse's way because I want to make sure that we focus on that one now, and then we'll move on. So these slides are here to support, particularly if this is something that you find daunting, that you have this here as a to rely on, that there's ideas here. Sometimes people would have asked me, what if the children come up with nothing? And this is the answer to that if you're doing a modeling activity where the children are solving things and generating their own models, that fear of if there's nothing, well, if there's nothing, you have these slides to revert back to. You have Pulse's way, Brain's way, Bolt's way to look at and to explore. But from my experience, with the new topic, the children are great at coming up with lots of different ways. And our numbers that we've used in these activities are specifically chosen so that it's easier for the children to come up with ways to solve it. But the slides are here as a support. And where I find them really useful is before I begin a lesson, spending 5 minutes going through them and seeing the ideas that are coming up on the slides means that then when I'm in the middle of a lesson, and if that comes up naturally, I know I can then skip the slide that touches on that point, because so much of this just comes up naturally as the children reason and as the children are communicating and using their maths talk and generating their models. So just to look at the whole setup again, you have, similar to the previous slide where I had the pictures of the children's work, here you have the task and the 4 different possible strategies. And again, there are other strategies as well. It's not that these are the only ways of solving it, and we don't expect every child to solve it in every way. If we go back to what the curriculum said, individuality, flexibility, creativity, and that whole appreciation that there's more than one way to do something. It doesn't mean you have to be able to do it every way, but it means that if my only way to do it is to do repeated subtraction, like Brains' way there, if that's my strategy, that's equally valued, that it doesn't have to be the most efficient strategy. Maybe I'm not ready for that yet, but I still belong in the classroom. I still my thinking is still valid and I still have a way to solve it. So the slides are there to support that and to help as you're doing this with your classes. So next thing then is to see, this is an example that I did with my third class this week. So it's just, what does this look like now in my own classroom when I'm using Maths My Way? And we were doing fractions last week. And this was one of the first tasks we looked at. So it said Pulse had 24 buttons. Pulse gave a quarter of these buttons to Brain. How many buttons did Pulse give to Brain? What fraction of the buttons did Pulse have left? And how many buttons was this? So set up again as a story problem with Pulse and Brain and buttons and sharing them. And this was new for the children. So there was no they had no formal way of doing this yet. And we're going to look at some of the models that they came up with. They drew them on whiteboards, but I just recreated them on Polypad to show them here today, some of these ideas. So the first child drew out 24 buttons and split them in half, drew a line down the middle, and then each half split that in half again. And recorded 6 underneath each set, and recorded that 6 plus 6 plus 6 plus 6 equals 24. And this just happened organically with, they were the only child that came up with this, that group down in their seats there, this was unique individual to that group. This was how they were going to do it. And then they used this, they used this idea of drawing out the set and splitting it repeatedly throughout the lesson to help them solve the next problems that we came up with. Had another child who didn't feel that the visuals or that was needed. They wrote 24 on the side really big and drew a line beside it. And they wrote down that half is 12 and a quarter is 6. So they've moved beyond the visual. They're thinking about that idea of half at first and then half the half again, which probably comes back to some of the paper folding we were doing in the lessons before this, I imagine that's where that idea came from. But it was a strategy then that they could use to help them figure out what a quarter of 24 was. To another child, that again is a similar idea of getting half first. They drew out the 24 buttons in a different arrangement, and they halved it horizontally first, and then quartered the top half. And with their calculation, where they wrote 12 take away 6 equals 6, that's like they were taking half first, the 12, then taking away 6 from it, a quarter, which was left leaving them then with the final quarter, which was 6. So lots of different strategies so far going on, but harking back to the same ideas. Even though they had different models to explain it, a lot of these were harking back to the same idea of half first and then half the half to get the quarter. We haven't touched on division yet in our class. Division isn't something we've looked at yet. It's coming up in a couple of weeks' time for the first time. But there was 2 children who recorded 24 divided by 4 equals 6. So here you can also see your differentiation. With this task, you had some children who were drawing out and really relying on the visual to figure out what a quarter of 24 was. And then you have another child who is using division before we've even looked at it as a class. So there's the low entry point that everyone can get started, but there's a lot of room to explore it in different ways and to think about other people's ways of doing it. Just looking at them all together, we put these ideas up on the board at the end with the children's names beside them. And we're looking at all of the different ways that the children model their thinking. And the children are learning so much from each other when they see these. Some children will pick, someone who was maybe finding it difficult might look at the drawing and they might decide to try that next time. That whole idea of halving first and then halving that number again really took off, and having the children explain it in their own voices is often a lot more powerful than just listening to the teacher's voice. And again, back to what I said at the very start about if I got notified of an inspection, here we can see lots of different reasoning going on. And we can see lots of opportunities for communicating during whole class discussion. children explaining their ideas and learning from each other. Huge scope for it. So we've spoken about mathematical modeling now for a fair bit, near 20 minutes already, without touching on concrete resources. And that is quite deliberate, because concrete resources are really important in maths, but they aren't the be all and end all. I would say when you're using them, that why and how the children use the resources is just as important as what they use. So sometimes, like, and I've done this myself, I still see myself doing it sometimes in September, is like, what resources do I need? Or I think sometimes if I just get the right resources, everything will just fall into place. But it's not just about what resource you have. You always start with what is the lesson focus. That's always the most important thing in a lesson. Then what tasks are the children engaging with? And the task is like a question or a problem or an activity. And then what concrete materials will support their understanding. So I'd never start by saying to myself, I want a concrete resources lesson today. It's always about what are the children learning, what's the task they're working on, and then what concrete material will support their understanding of that. And then how might the resource be used to develop the understanding? So they're excellent to have in your classroom. And we recommend having a maths table in your room where the different resources are available, and certain children will want to draw on them at certain times or want to pull them out to help them with certain tasks, but they may not be needed for every child. If we go back to the ideas I had on the board or on the slide earlier, where the different children were solving fractions in different ways, some children there might have, they didn't, but some could have gone up and taken some of the counters we had and solved it using the counters, using them as buttons. But there was also children whose thinking was beyond that, who had, moved on to doing 24 divided by 8 and recording it in a division sentence. Now, with that child who had moved on to recording it as a division sentence, my next question would be to probe into, like, what understanding was there to back that up, or what did they mean by what they had written? So I asked them to draw a picture to help explain what 24 divided by 4 looks like, to get into it. And again, that's them generating another model to go with their division number sentence. Final message on concrete resources is just that I would say it's better to engage deeply with a small, well-chosen selection of materials than to have every concrete resource under the sun on your shelf. And paper, like I'm going to talk about next, but keeping it simple, like having counters, the interlocking cubes, the Dean's blocks, paper for folding, they're really the essentials that come up again and again and again. But there's also lots of replacements, like lollipop sticks can be just as useful as cubes, and it's whatever works for you and what budget allows for. The example I wanted to show was that idea of paper folding, because when it comes to fractions in particular, paper is one of the best resources you can use to help you. Again, we were very lucky to have DCU visit our school for the past number of years to help us look at how children learn fractions and how we can support better understanding of fractions. And they came up with a series of paper folding lessons that turned out to be so powerful in helping the children to visualize fractions, to have a better conceptual understanding of what was going on. And I really emphasize that for fractions, just having that is so powerful. So here in third class, the activities start off with getting paper, getting small squares, and folding them, cutting them, actually getting to see the halves, counting numbers of halves, counting numbers of wholes, and really having that visual representation. Something like paper or lollipop sticks are great because you can have a huge amount of them without it costing a huge amount of money. So especially for something like fractions and having the paper, like you can create so many of these so quickly, and the children can create their own. Whereas if you were buying fraction walls, like that would be really expensive. And when the children make these things themselves, they're often much more meaningful because they've been involved in making it. They're seeing the physical cutting from one whole to halves. So in the first activity, it was all about the paper. But then in the more traditional looking activity, where they were writing one whole equals how many halves, they still had their paper to draw on. And like I said earlier, some children relied on that paper a huge amount. And other children were able to fill these in without going back to their paper at all. So lots of differentiation happening as well. Next, there was, or actually in the next lesson, there was a problem where it's all about brownies. And Bolt has 6 halves and 8 quarters. Wind has 3 whole brownies and 16 quarters. And Brains has 1 whole brownie, 4 halves, and 12 quarters. And this is one where the children can go back and use their paper squares again to investigate who has the most, who has the fewest. And again, different entry points, different ways to model this problem. Some children went back and actually got the squares and were cutting them up and physically showing what it looked like. Some children were drawing, so they were drawing what the different characters had instead of actually physically making it. And other children were working with numbers and symbols, and they didn't feel they needed to draw it out at all. So again, huge amount of a variety of different ways, and that brings that individuality back to it again. Okay, so I hope that was useful on the idea of modeling, as we're going to look at Polypad next. So as I'm getting Polypad loaded up, if anyone has any questions about anything that's happened so far, feel free to drop it in the chat and we'll get to it very, very shortly. So hopefully now everyone can see Polypad on the screen. So this is the resource that was on in the video at the start, where it's embedded into the slides. So any of the interactive features or any of the interactivity is powered by Polypad, and it's a really excellent resource. So I'm going to look at some of kind of my top 5 features, the things that I really enjoy in Polypad that I find are great in class. You have the pre-made ones within the slides themselves, but Polypad is there for everybody to use. You can easily just go to the website. You can see it up there, polypad.amplify.com, and there's a huge array of things there that you might like to use with your class. When you first log on, this is the page that comes up. They have their own tutorials as well, if you'd like to learn more about them. But we're going to look at a few today. So this is just a completely blank Polypad. And when you go into it from the website, you have the full range of features down the side here. So it's broken up into the different subcategories. When you go in on our pre-populated ones through the slides, there'll be limited menus there. We've adjusted them for just to be suitable for that activity. So if you want the full menu, just go into the website itself. The first thing is over in grids and displays. You can change the background to different backgrounds that you want. Huge amount of options there to suit your class. And the first thing that this is my kind of go-to, let's say the best tool to go with Polypad is definitely, my favorite is the fractions. Although I might be biased because, as I mentioned, it's one of those topics I like teaching the most. So in the fraction tools over here, you have an option. You can go with fraction bars or you can go with fraction circles. I love the bars because if you have the children working with paper strips where they're cutting up strips to make different fractions, these bars are just a digital version of the same thing. For the senior classes, you can change them to percentages, you can change them to decimals, or for the really junior end, if you're just looking at fractions like without formal notation, you can take that off completely and you can just have blank strips as well. So what I love about these is you can pull them out, zoom it down so we can see a few more. You can compare different fractions, so you can pull out a half, make it smaller, compare it to 3/5, which is greater, which is the smallest. How can we tell? Then you can pull out different fractions to compare them. So like a half is the same as how many tenths. 3/5 is the same as how many tenths. There's also the tool here, the rename tool on the device, on the system itself, where you can rename them if you're looking at getting common denominators. You can even look then at like combining different fractions and subtracting fractions. So if I wanted to know, well, what is a half plus 3/5? And here I can see, well, I know it's bigger than 1/2, and I wonder how much bigger than 1/2. And then even at a basic level, I can test different amounts. Like a quarter is too big, that doesn't match up. But if I add on my tenth, that works there perfectly. This works really well on devices as well, on iPads. And the thing I love about Polypad is that it works really well on interactive whiteboards too. The touch features just work great on the board. So I find the fractions really useful. And for visualizing all these things. And I think especially if you start with that idea of paper strip folding, it's a lovely one. And the next one is in geometry, to look at some of the different shape tools that are there. So I'm just going to pull out pentagon. I can make it bigger if I want. I can zoom in, or I can just make it bigger here. And there's so much you can do with it. So if you hit play, it will go around and it will count each of the vertices and the edges, and it'll play a little note. You probably couldn't hear it there because I didn't share my sound, but it'll play the note to go with it as well. With the shapes, you can cut them. So, and it's good for like recognizing what you're trying to cut. So like cutting the middle of the shape, you see how it kind of snaps there to the center, and you get the two halves of the shape. You can flip the shapes. You can test that they're whether it's symmetrical or not. So much there you can do. I love when you're trying to use lots of different shapes. Feature I like is just clicking up in the corner and dragging down to select more than one, and then you can move them both together. Or if you want to make multiple copies, just click copy, or duplicate. You can do it again, and it's really quick to get loads of the same picture repeated. So they're your basic shapes. You also have the pentominoes and the all those shapes there for you that you can drag out and use. They come up throughout the series, and you have your tangram shapes too. So sometimes, especially if it's the right angle triangle that we've used in an activity, they're from the tangram pieces, so they're down there as well. So huge amount of shapes there to look at, and different tools that can be used with them. Next is the 3D shapes, and this is one again that works very well on devices and for when you're exploring maybe building nets. So on the Polypad, you can build 3D shapes from the 2D pieces. So here I've made the net of a cube, and if I select them all and click Fold Net, it'll fold them in to make the 3D cube. And you can unfold gradually to see what it looks like. You can also pick different squares. Okay, you can pick a square and change the color to see what different bits will look like when it's folded up again. Might help children to visualize what's going on when it's folded, just to help see the difference. They also have pre-populated 3D solids. So they have the octahedron there, and these different ones are here that you can fold and unfold to see what the nets look like. But you can create them anytime they come up in the book. We'll have them there for you. But just a lovely way to test out, and one that you know that problem where the children have to find all of the different nets of a cube. This is a great way to test it. Because the equipment, the actual physical resource that would be needed, like mag formers, can be quite expensive. Whereas, if you have devices, it's a nice way of looking at them. Next one is down in our algebra tools, and this is a tool I've only recently started using, the balance tool, but it's so useful. So it's this whole idea of balancing equations and so much that can that can be used with it. So like if I go down to my currencies and I go to money, I can put €2 on one side and €1 on one side and ask the class, well, what will balance the scale? And they'll pick what to put in and make it balance. Again, with devices, children could create different versions of this for a partner and, you know, have some challenges for each other. Back in numbers, I can also put in my place value, my base 10 equipment to test it out. So, you know, all of the equipment works in it. I could use cubes with the younger classes. You know, what do I need to put on the other side to balance this? All of the different things that they have here work with it. So it's a great tool for looking at equations and that early addition part whole models, all that, getting it like looking at what how to balance an equation. Similarly, in the algebra tools, you have the function machine, which is lovely. So here I can pull out my function machine, and it's currently set to x plus 1. So whatever I put in is going to it's going to add on 1. So if I was doing number facts with my class, and maybe I was looking at the whole idea of plus 9, okay, and I'll have a card out this side, and you can ask the class, well, what do we think is going to come out the other side when I put in the card 9? And then it'll show it for you, and just a nice tool to have. Over on the left, you can change that to anything. So you can change it to a fraction by putting in 1/2. You can put in your decimals. Pretty sure you can put in some of the other manipulatives that are there as well. So there's it's just a lovely tool. You can also change it. So if you hide your screen from the class and click on the menu option down here, which is these 3 dots, and toggle off show expression, now they have no idea what the function is. So you could put in a few cards and they have to guess what the function is set to. So, you know, you can, this is useful in any topic you're doing. Like if I want it to be halving, I can just change it to, put in my fraction and change it to x divided by 2. And then I could ask my class, okay, well, if I put 18 in here, what's going to come out if I'm halving it? What will half of 18 be? And it'll come out the other side. So really love this tool. It's kind of applicable to so many different topics. But a nice kind of warm up with maths talk, with reasoning, with think, pair, share going on as well. Very finally then, just 2 kind of bonus things to look at is our dice. So we have our 6-sided, 8-sided, 10-sided. They're all here for you. So might be useful sometimes if in certain games you're playing with your class or activities you're doing. You can also tabulate them if you're doing something with probability. And very finally, we have in our school, we have focusing on chess at the minute. So there's a lot of we're playing chess with some of the classes, and here you have your online chessboard as well. Just by clicking reset, it fully brings it in. And it's a nice way to, you know, share some ideas from chess. We're using the fiddle.ie resources, and just a lovely way to share it in front of the class and have that part of the lesson. So hope there was something there for everyone. I will just go back to what I said at the start and say everyone is doing an absolutely amazing job. You know, everyone is doing, like, to be here on a miserable wet evening in November, you know, deserves so much credit. And hopefully there's 1 or 2 things you could take to bring back to your class with you.
Patrick, I have a special request before you hand back to me.
Oh, yeah. Well, what is it?
Put the Dean's blocks into the function machine. I didn't know it did that.
I hope it does.
It does. I checked it while you were doing it. So,
Yeah.
which is just to show that Patrick and I are still learning all the very cool things that Polypod can do, and hopefully some of the children in your class get as excited about it as we do. But let's go and answer some questions. So I'm just gonna share my screen here again. If you just bear with me for a second. Oh, I need to skip on quite a bit, so I might just jump out of this briefly. Patrick has obviously been through all of these slides. Okay, so first of all, thank you to everyone who shared questions in advance when you were registering. Can you see the screen there, Patrick? Is that coming up? Right, yeah. So I'm just going to run through some of the questions that some of the frequently asked questions that we got in, and then there's a couple more in the chat already. And if people want to keep dropping stuff into the chat, I'll pick it up once we've gone through these. I wanted to just say, first of all, anyone who's having any kind of technical issues, there's a couple of questions that came in along the lines of, finding it difficult to navigate the program, find what you need, or even just basic things like navigating through the slides. Like if I'm on slide 7 and I want to get back to slide 1, how do I get there? So you might have seen at the beginning when we opened up the webinar just before we started, there was a Getting Started with Maths My Way video playing on the screen. That video is available when you go into the plan section on library. No matter what class you're using, that will be the first resource that's there. You'll see it there. It's Getting Started with Maths My Way under plan. And that will take you through all the basics of where to find things, how to edit things, how to navigate through the slides, and there's lots of different ways to do it as well. Lots to get your head around because it's it's a new program with new features and functions and all the rest. So I definitely recommend having a look at that video. But if you're still having any technical issues and you need a little bit of help with something, don't hesitate to get in touch with your local rep or with customer service here at Folan's. I'm very happy to help you. And just make sure you're getting the most out of the program. So let's have a look at some of our content queries then. I included this one in the hopes that we have helped to answer it already, which is, where do we start with modeling? We've got our kits together for our senior classes, and I know that's something that a lot of teachers spend time doing for the new curriculum, is getting some more of those concrete resources together. So I hope that from what Patrick has shown you this afternoon already, you have some ideas about getting started. But if you want any more specific direction and you've got maybe other questions, feel free to drop them into the chat and we'll have a look at them now. Here's one for you, Patrick, just about order. So is it recommended that we follow the chapters in order or group similar topics together, for example, doing 3D shapes after 2D shapes?
I would like for certain topics, it is quite important. So we had I'm thinking of our measures units that have decimal work in them. And we were very conscious as we were writing the series that the decimal content came before it came up in a measures unit. So if you skip to a measures unit that's at the end of the chapter or at the end of the book before they've covered decimals, they might meet something in length or in weight that they haven't encountered in just number yet. So things like that are matched matched in that way. And certain topics then, like if there's division 1, 2, 3, 4, obviously the order there is very important. But moving certain other things around would have less of an impact, like moving some of the shape and space. Again, there are ideas that connect throughout the 4 shape and space modules. So the order they're written in, if you jump to the 4th one first, there might be something that you're like, oh, they've no idea how to do this. And it might have come up in the previous unit. So they were built sequentially in the way the book is written. But the transformations unit is obviously not connected to the division unit. So moving around in that way wouldn't matter.
Yeah, I think that's a very good answer. And I think there's a huge amount of time went into actually planning that out. I mean, it was a mathematical problem in itself about, what orders to do things in. And some examples come to mind are like the interplay between fractions and division in 5th and 6th class is massive. So doing those units in the order we've set them out will definitely make things make more sense. And another example that comes to mind is we do transformation on the coordinate plane in 6th class, but you need to have explored the coordinate plane in spatial awareness before you get to that, so that you're exploring what the coordinate plane is before you go and do transformation on the coordinate plane. So there's some obvious connections. But that's not to say you can't move other things around. Patrick, you've said before about what your school are kind of doing this year in terms of your yearly plan, which might be useful advice to share.
Yeah, so like I wouldn't recommend anyone starting a new or like having a finished whole school maths plan at this stage because it's also new. What we're working on at the minute is we've a maths committee set up where we're looking at how do we get on this year. So, what's actually manageable to cover in a month? Is there things we want to move? Is there certain topics that might need a second week? And we're building up that bank of knowledge this year so that when it comes to having a long-term plan for next year, that we have that bit of information to adjust it and to make it match our own school. Because every school is going to have different contexts, and it's about moving things to make it work for you.
I think that's very true. It's important to remember that, you need to have that bit of flexibility and tailor it to your own school as well. But take it easy and go slow with it because there's a lot of figuring out to do. There's two questions here which are quite closely related, so I've included the two of them together. One of which is just teaching the new curriculum to senior class to DESH students who are finding it hard to adjust and they're missing the basics as a result. And then kind of related to that, how would you support the children in your class who are finding the content difficult?
Yes, and I'm going to add in, there was a saw just while you were talking a minute ago there, Kira, I saw a question in the chat where someone asked about one
Pace.
child being finished instantly and another child still being drawing, and how do you support that? So one on the polypod side of things, one thing that I find quite useful for certain topics is having if you have an iPad in your room, even if it's just one, having that with you as you go around to different groups to help demo is a lovely way to get at to help the children make sense of what's going on. So, if you have that resource in your school, if you have access to an iPad for certain topics, having that in your hand as you go around to different groups is really useful. With the idea of children being finished at different times, I was really lucky a couple of weeks ago to get to go to DCU. They had a teacher over from Japan, a Japanese teacher, and a Japanese maths teacher, and his translator with him, and they were teaching a lesson to a class of students, and he brought that idea of differentiation. Like it was so good what he showed, that it was the idea that just because you're finished doesn't mean that you kind of shut off. That it's trying to build. He was trying to build a community at each table, each mixed ability group, that yes, you've done it, but you're not finished because there might be someone sitting beside you who still needs a bit of support. And to see the children working at their tables, helping each other, explaining it to each other, like there is no worse feeling in a classroom than you're trying to help one student and there's about 10 hands up round looking for you all at the same time. Like that has to be the worst when that happens. But this idea of when the children are finished, they become little mini tutors themselves, and they're helping the people at their table and not just showing them answers. It's not just copying off each other. They don't bring their copy with them. It's all about that maths talk, explaining and helping each other. And often, the way a child will explain it to their friend might just click better than the way an adult would. And I've been using it since, been trying that out with my class, and I must say it's working really nicely. You can see it helping helping in the room.
Yeah, that's really lovely. And actually, you've jumped ahead to the question about pace as well. So I think you're kind of covering that too. I think it's also worth mentioning that there are, extension activities and things there for children too, and it's not just extra work. That's something we were very conscious of when we were going through it, that any extension activities in the book, they build on what the children have already done. So it might be something as simple as, can you find another way to do this? Which links back to what Patrick was saying earlier about modeling, like finding another way to model an answer, or draw a picture to support your thinking. So that's, sometimes it is just about going that little bit deeper and kind of pushing them a little more, like Patrick was saying about the the child who wrote, 24 divided by 4. It's like, well, can you draw the picture to go with that so they can see your thinking? So I think there are lots of ways to differentiate in that respect. And it's different, it's new. If that's not what the children are used to doing, I'm sure it takes a little while for them to get used to doing that. You've obviously had that experience, Patrick, over the last couple of weeks. Did the children take to it well?
Like, and I mentioned it at the start about how if it's a new topic, so like when we were doing addition and subtraction, that's something that they've been working on for 4 years when they reached third class. So that was very hard to go back to the modeling again, because there's so much groundwork done there. Whereas when we do a topic like when we were doing fractions and it was their first time looking at it and it was with the new curriculum, the lessons flowed so much nicer. But as the children use the scheme and use the new curriculum, year on year that'll get easier. So if they're coming into third class with having used the new curriculum in second class, then you're going to see that those chapters that are hard this year should be a little bit less hard next year, a little bit less the year after, and gradually get nicer and nicer to teach as well.
Yeah, that's I think that's really wise, actually, and it's a good thing to remember if you're in 5th or 6th class right now. And it's a little bit trickier because we have to remember those children have had 6 or 7 years of doing things certain ways.
Yeah.
So it's going to be gradual. I've got 2 more questions, I think, here. One is just about kind of your groupings. Do you recommend mixed ability groupings or having children who are at a similar level working together?
So I recommend having tables with mixed ability at each table. I find that children having someone like a maths partner or whoever they're working with to talk to during the lesson is very important, and maybe similar levels there are useful. But having that mixed ability grouping at each table is important, so that, if you use the approach where, now let's see if there's anyone at your table who you can help, that there's that mix there.
Okay, great. And then this is quite a long one, so bear with, although I do love a good specific question, a specific example. So this is a teacher who kindly shared this with us, saying, I was doing subtraction with the first number missing. Sorry, I misread that originally. I was doing subtraction with the first number missing. So it's, for example, when you've got that like box minus 6 equals 12. I tried explaining that we add the numbers. I used a number line and an abacus to show it. I said my answer is 12. I took 6 away to get that answer. So if I add the 6 back on, I'll find the original number. But a lot of the class just didn't get it. They didn't understand. I'm wondering if you have any other ways of doing this, bar telling and experimenting with the idea that something minus 6 equals 12 is the same as 12 plus 6. I feel like I'm giving them a formula rather than an understanding.
And this is... First of all, this question, like this idea of something, the blank space at the start caused huge confusion in my classes all this year. So it's not unique to this teacher. It's this, and I think it comes back to that: is there reasoning going on? So children are used to seeing number facts with the answer at the end, or the empty box at the end to fill in the answer. But unless they're thinking about the different elements of the number sentence and what each part means, we're losing a bit of reasoning there. We're losing some understanding. So deliberately in Maths My Way, we try to move things around a bit. Sometimes the answer comes first, but that takes time to get used to as well. So with this example, it really got me back to that idea of the balance, and like here having 18 on one side of the balance and 12 and 6 on the other side, and seeing all of the different number sentences that can be made using the balance. So what addition number sentences can you write? What subtraction number sentences can you write? And then you could go back to your frame like this with something, take away 6 equals 12, and how can I use now what's on the balance to help? But these things, like you're going to come up with things that your class finds difficult, and that's your assessment. It's brilliant. And then it's how do you focus on them? So for me, for the last up until midterm, my focus was addition and subtraction with renaming. And we did like 3 times a week, we did a question every day, just on the whiteboard. I'd put 2 numbers up on the board, they'd add them together and they'd subtract the smaller number from the greater number. Now I've moved on to finding halves and quarters of a set because that's an area that they need a little bit of focus in. So no matter what topic I'm doing, I'm spending 2 or 3 minutes at the start with a couple of questions. They need the repeated practice, but in an engaging way as well, that it's not like, there's extra opportunity to look at these ideas that as a class we're finding difficult, but it's not just pages and pages of sums or pages and pages of fill in the blanks.
Great, that's lovely, Patrick. Thank you. And then I've got a question here, which I think should be up your street if we can jog your memory a little bit. So as the teacher said, I'm currently teaching 6th class division, and those were your units you worked on, so probably the right person to ask. Do you have any ideas for classroom activities I could do with them, or any advice for 6th class division or shape and space? And I asked this teacher if they're using Maths My Way, and they are, and they said they did the dice game with the function machine today. I actually can't remember that one myself. I don't know if you do.
This is like, and I meant to say it a minute ago and I didn't, but I think it is like, as we said, it'll get easier teaching the new curriculum year on year, but the inverse of that is that it is hardest at the minute for our 6th class teachers, because they're the teachers who the children, there's so many topics that they haven't had the new curriculum experience with. So I'd say when you're teaching 6th class, like, don't be afraid to go back to the 5th class version. There's loads there as well. There's extra units on it. If it's a topic that, like as I said at the start with modeling, if it's something that the children were really drilled last year on how to use the algorithm, and that's kind of like, you're finding that they just won't model for you because they really just want to do it the efficient way, which is you can understand as well. Don't be afraid to dip back into a page from an old book as well, because if that's how they've done it previously, use that as a resource as well. But there's go back, like having the 5th class one there is huge for if you're trying to start something for the first time, but the 6th class version assumes that they've done something in 5th. Don't be afraid to jump back into the 5th class one. You've access to all of the ebooks for your school on my phones.
Yeah, absolutely. And I think that's the thing. It's don't be afraid to go back into other books, but also your old books. If you've old Planet Maths on the shelf or whatever's there from before, and like Patrick said, the children are very used to doing something a certain way. There is, as long as you're still thinking about reasoning and maths talk and all those new pedagogies of the new curriculum, it's okay to kind of dip back into other content as well. It's a gradual change. It's not going to happen overnight. Lovely tip here from someone actually in the chat saying that go back to that idea of the missing number and where it is in the sentence. So this year I focused a lot on the equal sign not being a question mark, but rather a balance scale. We banned the word equals for the whole month of October and used is the same as instead, and found the shift in mindset to be very helpful for students modelling these types of questions, which I think is lovely. And using Polypad for that as well with the balance scale that Patrick showed would be a lovely way to kind of bring that to life as well and kind of show it in a very visual way. So I think that's really nice. That is all. I think that's all the questions in chat. I hope I haven't missed anything. Just very, very briefly, we're also after nearly 25 now, so I'm sure everyone wants to get on with their evenings. But just to mention, we will be back in spring with more webinars, and we're going to focus in springtime on some of the kind of new curriculum topics, so some content that you may not have seen before. So some of the transformation content comes to mind as a main example, but there's also things within algebra, within some spatial awareness, even some of the things we're doing in number, which are new in the curriculum and may not have been explored previously. So we're going to run some webinars in springtime focusing on those. And those topics all come up later in the suggested year plan in Maths My Way. So we'll time them when they're likely to come up in your classrooms. So you'll keep an eye on our social media and our emails and stuff for when those are coming up. If you do have any further queries or require any additional support, please don't hesitate to contact your local rep. They're always there to help you out. You can find, if you don't know who your local rep is, you can find their details on our website, or you can contact us at customer service info@folans.ie. And finally, if you are on this call and you're not using Maths My Way, I imagine most people are, but if you've just joined to learn a bit more about mathematical modelling and a bit more about Maths My Way, and you like what you see, you can try some of our resources on folens.ie. They're totally freely available, or you can get a full trial of the full programme on my Folens library. So yeah, I think that is everything. Thank you all very much for joining us, and hope to see some of you again in springtime for some more webinars.